Hi, welcome back. In the previous class, we discussed about a simple DayTime client program. So, a program that we are going to write on the client side to get the date and time from the server side. In today's class, we will be going to discuss about a simple DayTime program, but on the server side. Because whenever we get a request, suppose if I am a server and if I am getting a request from the client, then how this request will be provided service, how do I provide service for such request? So for that I need a program, so that is server side program. So how to write the server side program to respond to the request that is received from the client? That structure of such a program is what we are going to study today. Most of the instructions that we used in C program for the client side, similar instructions are used on the server side as well, but with certain simple modifications because it is a server which is responding. So from the server point of view, the program and the logic will slightly change, and we will discuss what is that change that is required or that is necessary on the server side. So creating a socket, as you see in this line number 10, it is similar to what we have used in client side, because creation of socket is nothing but combining the IP address and the port number. So it is just a simple process. So creating a socket, whether it is on the client side or server side, it has to be the same. And here what we see in this, especially where I am pointing here, if you see, I am creating a socket with the parameter AF underscore INET. So what it means? It means that the program or this server side program is making use of IPv4 protocol. Correct. So it is not AF underscore INET 6. It is AF underscore INET. It means it refers to IPv4 protocol, and it also means that the program is protocol dependent. So this program cannot run for IPv6 addresses. Okay. So that is what we can understand from this simple example. We will discuss about how I can make it generic later. Okay. So moving on. Uh, in the line number 11 to 15, so if you can see, it has been blocked. The line numbers from 11 to 15, what do they say? It's the server's well-known port. So I am making use of port number 13, that you can see it in line number 14, H2NS, that is host to network. So from the host side, from the host name, I want to convert it into network understandable format. So we use host to H2N function, host to network function. So there I'm providing 13 for the daytime service, and is bound to the socket by filling in an internet socket address structure and calling bind function. So bind is the function that we use on the server side, and it is not used on the client side. Okay, so I will discuss more on that, on bind function and all other functions later. But just we need to understand that bind function is used to combine. It is used to bind the internet socket address structure by the bind function, and then we specify the IP address. And IP address is provided in INADDRNE. So if I point it here, you can see H2N, that is host to network long, INADDRNE. So it means internet address any type. So the client can have any address. It can be IPv4 or IPv6 or any address that is supported or that is accepted a request from any kind of any address. So that is the macro that tells the server that it accepts any type of address from the client. So which allows the server to accept a client connection on any interface. So we will study how to restrict it to a particular interface later. Then in line number 16, what we see is we call the listen function. So we can see the listen function here. You can see the listen function here, but again, if you observe here, the first letter of the function L is capital letter. Similarly, for bind function, B is capital letter. It means these are not the inbuilt functions, but they are the wrapper functions. Remember, they are the wrapper functions. So but inbuilt functions also share the same name, but they are all in small case letters. So it means listen function, bind function, whatever we are using here in this program, they are in turn calling the inbuilt listen function and bind function respectively. So in line number 16, what we see here is by calling the listen function, the socket is converted into a listening socket. So the socket that we have created on the server side, it is not meant for sending a request, but it is meant for listening to the request that is being received from the clients. So now the socket is listening socket, hence the function listen. So listening on which the incoming connections from clients will be accepted by the kernel. But these three steps, that is socket function, bind function and listen function, they are the three major functionalities on the server side. They are the normal steps for any TCP server to prepare what we call the listening descriptor. Like how we have a socket descriptor, we have listening descriptor on the server side, and it has been named as listen FD. So that in this example, in the listen function, you can see here, if I point it at listen FD, or maybe even if I go to the previous slide, you can see here listen FD is the listening file descriptor. It holds the number of the listening file descriptor. So that is the meaning. Okay, so the constant, we also refer to the constant listen queue. So the and this constant is predefined in the Unix header file, that is Unix programming unp.h. In that header file, it is already predefined, and it specifies the maximum number of client connections that the kernel will queue for this listening descriptor. So as we know, this is a server side program. Okay, I'll move on to this next slide. Okay, so here you can see, I'll again point it out here. You can see listen queue all in capital letters, though this is a constant which is already predefined in the header file. Okay, so this, what does this particular listen queue, what is the purpose of that? So whenever the server is trying to listen to the client, we know that server is not going to communicate with only one client at a time. There can be n number of clients, possibility. So there can be n number of clients trying to communicate with the server. So what is that n? What is the capacity of the server? Can it handle 100 clients at a time? Can it handle 1000 clients at a time? So that number, that limitation is fixed, and that is the constant that is defined by listen queue. So this listen queue maintains a queue of all the clients that are trying to connect with the server, and then accept client connection and send reply. So once the server is ready, then whenever there is a client request, the server has to accept the client connection and then send the reply. So that happens in the line number 17 to 21, the next block of statements. If you see line number 17 to 21, normally the server process is put to sleep in the call to accept function. Okay, so it is usually put to sleep, waiting for a client connection to arrive and to be accepted. So a TCP connection uses what is called the three-way handshake. I hope you all remember the three-way handshake. Even otherwise, we can discuss in the later session about the three-way handshake in detail. Okay, so when this handshake completes, the accept returns and the return value from the function is new descriptor. So whenever a whenever a connection is established with the client through the accept function, we see that there is another variable here, that is confd. If I point it here, confd, that is connection file descriptor. So using the accept function, whenever a connection is established with a particular client, a number is generated, which identifies a specific client, and that number is defined in connection fd. Okay, so that is CONNFD, the variable that we are using as the connection descriptor, and that is called connected descriptor, or it can be connection file descriptor. So this new descriptor is used for communication with the new client. So whenever a new client establishes connection, a new number is generated for that particular client. A new descriptor is returned by accept function for each client that connects to the server. So if there are 10 clients, 10 numbers or 10 connection file descriptors are generated by accept function. But how it is generated, that we will see. So in this block, we are also using the for loop, and you can observe here that the for loop is infinite. There is no initial value, there is no condition, no increment or decrement. So the for loop is totally an infinite loop, and you might have a question that can we write such an infinite looping statement in a server program? Yes, and this is intentionally. So this for loop, which is an infinite loop, this is intentionally made as infinite. That is because the only objective of this infinite loop is the server is always or infinitely trying to get connected with the client whichever is sending a request. So the client can send a request anytime. So the server must be ready anytime to accept and establish the connection and start communicating with the client. So with this intention, the server is always continuously running in an infinite loop. So the current time and date that is returned. So in the previous program, in the client program, we have seen that some date is returned by the server, and that date is displayed. So the current date and time which is there on the server, it is how does it get? It gets from the, so we have written a program to get the current system date from the library function time. Okay, so this time is a library function, and that returns the value in seconds, the number of seconds. So the next library function that we are using is cTime. Okay, so if you see, so the cTime converts this integer value into a human readable string like Monday, July 27, whatever date that is there in the server machine, that will be converted into this string format. And a carriage return and a line feed are appended to the string. So whenever this date is date has to be sent as a string to the client machine, the entire string will be suffixed with the line feed and a carriage return. So this is not possible in the normal printf or sprintf function. So to add this carriage return and the line feed at the end of the string, we use another function called snprintf. So there is another specialty of this snprintf. I'll just tell you in a few minutes. So first we'll understand that snprintf function, which I will show you here. snprintf function is used, this one is used to convert this whatever time I have received in seconds, that will be converted into the human readable string format by the cTime function, and this entire string is returned. It is returned as a using snprintf with the carriage return, that is /r, and the line feed /n. So these two are appended to the given string, whatever the string format of the date. Okay, so that is the importance of snprintf. Another importance of snprintf is this is relatively it was a later addition to ANSI, and SNPrintf throughout this entire course we will be using whenever we are using this SNPrintf. It is recommended to use SNPrintf instead of SPrintf wherever required. So it is remarkable how many network break-ins have occurred. So there, why we also use SNPrintf. Another important thing is this SNPrintf has a limitation for in the form of a buffer. So we are specifying a size for whatever the data has to be sent on the client side. So sending the string to the client side is done by the write function, but what has to be sent, that is decided by the SNPrintf function, and this SNPrintf will fix the size. So you can see here in the SNPrintf function, you can see the size of buffer. So and this buffer is defined here. So it means the second parameter defines what should be the total size of data that has to be sent. Why it is so important, why this SNPrintf plays a very important role is, if the size is not fixed, then a lot of chances are there for hackers to add their own data into the program, and hence we will discuss more on the secured network secured programs in the later sessions. But this is one very important concept that you should remember. SNPrintf will fix the size of the data that has to be sent to the client side, and hence usage of SNPrintf becomes very important. On the same line, there are many other functions as well, like instead of strcat, I will use strncat. Instead of strcpy, that is string copy, I will use strncpy, that is string copy only, but with limited number of size, with a limitation in the size. So likewise, there are a lot of other options for secured programming. And at the end, the termination connection, that is termination of the connection, that is line number 22. I will use the close function, which will terminate the connection between the server and the client. So on the so the server closes its connection with the client by calling the close function, and this initiates the normal TCP connection termination sequence. And you know that whenever I initiate a termination, we say that a fin flag is sent from client to server, or from server to the client, whoever is initiating the close connection. In the three-way handshake, we will study that in detail. Okay. So with this program, there are a few takeaways, there are a few points that you need to note down. So the first one is like, as with the client, the server is protocol dependent on IPv4. So we have seen that we are using AF-INET, so it means it is dependent on IPv4. So we will study later how I can make it generic. And the second point is, the server handles only one client at a time. Though I have a infinite for loop, and though I have this listen queue that helps me to maintain the list of all the clients that are getting connected to the server, but this queue is used to maintain only the list of clients, but all the clients are not processed simultaneously. Every request of each client is processed one after the other. All the clients are not functioning simultaneously, but yes, we have advancement which we'll study later, how to handle multiple clients simultaneously. So we have a function called fork. So that is the third point. We use another function called fork, and with which I can do, I can introduce the concept of threading, wherein for every client a thread or a child server or child process is created by the fork function. And the next point is, the server in the program is called iterative server because it iterates through each client one at a time. So whatever server program we have written here, which maintains the queue of the clients, it is called as iterative server because only one client is processed at a time. And the last point, if we start server like this from the shell command line, we might want the server to run for a long time. So since servers often run for a it might take a longer time. If the system, if every client even takes some seconds or a minute, then it becomes a very long delay. The server has to process for a very long time because it processes one at a time. So another concept is the server has to have the capability to run continuously for a long time in the background. So such processes which are running at the background for a longer time and keep processing, we call them as daemons. Okay, so server program act like a daemon process. So I think with this, I hope you got an idea of what exactly is a server-side program and how server is going to handle the request from different clients. So a single client might have multiple requests, but usually server is designed in such a way to handle multiple clients. So how multiple clients are handled, is it one at a time, or whether we can handle simultaneously? All that we will study in detail in the forthcoming sessions. Thank you.